Let's look at some angles in parallel lines. Before we get started, we're gonna go through a few quick rules. Like, for example, the minute two lines cross each other, then the two angles that are made opposite each other are referred to as vertically opposite, which means that A is equal to B. And just the same way, whatever angle is here is going to be equal to the same angle there. The next rule that we're going to have to look at is angles that are alternate. So this happens when you have a pair of parallel lines. We know they're parallel. Usually in maths, a couple of arrows will be placed on them to tell you they're parallel, and any line that's cutting these parallel lines is known as a transversal. And these transversals tend to make some angles. Now I will shade over in red some angles we can see. If the angles are alternate, then these angles within the shoulder of the Z will be the same. So I will call this A and call that B, again showing that alternate angles are equal, thereby telling me that A and B are the same. The same thing happens for this side of the angle as well, because these are also alternate. If I want, I can call that C and D, and the same rule applies to say that C and D are also the same. Another quick rule we can look at, same with the parallel lines again. There are all little arrows, and there's my transversal again. I can look for corresponding angles. These angles are also equal. And how do you find corresponding angles? Well, they're in the same position. So in this case, A and B will also be the same. And when I say the same position, I mean if you look very carefully, this angle is at the bottom left hand side of the parallel line and transversal, and so is this one here. So if I want to make another angle in a different position, I can also say that that's the same. Like, for example, I could put an angle C here and an angle D here. These angles are on the bottom right hand side, and so by the same token, C and D are the same. I hope you notice as well that if I put an angle on the top right, well, it's vertically opposite to A and B. So they're also corresponding to each other, but by the same token, they will also be the same. Last of all, I'll tell you about would be interior angles. So what we need to know about interior angles is that they're supplementary, which means that if you add them up, they equal to 180 degrees. So if I have an interior angle, and you notice that they will be on the inside of the parallel lines. So I'll have an A here and a B here, and interior angles, when you add them up, they equal to 180 degrees. That's what the word supplementary means. Same way, I can have another angle here, C, and an angle D, and say that C plus D also equal to 180 degrees because they're supplementary. Well, let's take it for a spin in a quick question. Here's a quick question we can look at. Now, we can attempt finding this in alphabetical order. And so recognizing first of all that that straight line, all angles on a straight line add up to 180 degrees. So D plus that 50 degrees is supposed to equal to 180. which will now imply that D is equal to 180 minus 50, thereby giving me 130 degrees. Well, once I know D, I also know E in alphabetical order, because D and E are equal. And this is because, well, look very carefully. They are within the shoulders of the Z we talked about. Therefore, it means that they're alternate angles. So if D is equal to 130, so does E, equal to 130 degrees. Last of all, we can also say that F is alternate to 50 degrees, so F is 50, and both of these would be because they are alternate. Looking at a more complex problem here now, we do have some parallel lines, and we have quite a fair few of angles to find. So I'm going to try and get through them as quickly as possible, and I'll try and keep it in alphabetical order if that helps some people recognize what's going on. So let's go. A is going to be equal to 45 degrees because it is alternate to that 45 degrees. B, well, it's on a straight line with 107 degrees, as you can see there. So a quick little subtraction of 180, take away 107, because we know all angles on a straight line add up to 180 degrees. That gives us a quick answer of 73 degrees there for B. We can also see that C is alternate with B, which is also going to be 73 degrees. And I'll just write a quick note that they are alternate with each other. Now we're down to D. Well, we see a straight line there where C is known and A is known, and all angles on a straight line add up to 180 degrees. So that's really quick, just to say that angle D is equal to 180 degrees, take away C, which we know is 73, and A, which we know is 45, thereby giving us an answer of 62 degrees. So that takes care of D. Couple of things that we can do now. So what are we on? E. Now for E, E is pretty straightforward. It's also on a straight line with A. So a quick calculation of 180 degrees minus A, which is 45, gives us a grand total of 135 degrees, and that takes care of E. F is, as we can see, vertically opposite to A, so F and A are the same, which is 45 degrees. And last of all, G is vertically opposite to B. We know that B is 73, so G and B are the same, 73 degrees. And what started out to look like quite a complex problem turned out to be quite easy. Hope that was fun.